Welcome to the video where we will be finding n square with a formula. Now this formula might have already been derived by other mathematicians, but I could not find any proof online, so I think I might be the first one to do it. But if you know any other mathematicians who have done it, please mention them in the comments below. Also, I have attached a paper that I wrote about this formula, so yeah, just let me know and let's get into the video. So the basic formula is going to be n square is equal to n minus x the whole square plus 2xn minus x square, where x is the number you want to reduce n by to get to a familiar square. To better understand this, let's use an example. For example, here we are going to use 432 square. So n square is just 432 square, that means n is 432. And since we know the square of 400, or at least I know, we can reduce it to 400 by subtracting 32 from 432, which makes x as 32. So now we can say that 432 the whole square is equal to 432 minus 32 the square plus 2 into 32 times 432 minus 32 the whole square, and it gets us to 432 the whole square is equal to 400 square plus 27648 minus 1024. Now trust me, this multiplication will be much easier than 432 square on paper. So we can just open the bracket, simplify it, and we get this value, and if you plug it into a calculator you will find out that we are actually correct. So yeah, the final answer just becomes that. And my original formula, which I have not mentioned right now, is this. So this formula is basically telling you that if you know the predecessor of the number and the square of that number, then this is the formula you should go for, because this formula becomes much easier. It's just n square is equal to n minus 1 the whole square plus 2n minus 1. So for example, we are going to be using a different number, that's 61. And yeah, you can see, but the reason we are choosing 61 is because this is not really applicable in cases of big numbers, like if the units digit is not 1. So yeah, we're going to use a small number and have 1, so that's a 61. So 61 square is equal to 61 minus 1 the whole square plus 2 times 61 minus 1, that's 60 square plus 122 minus 1, and yeah, you get the final answer as 3741. And that just proves the formula. Now the reason I got that is actually, the logic behind it is this. So you see 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25. Now if you look closely, there is a pattern. You will see that 2 square is equal to 1 square plus 3, 3 square is equal to 2 square plus 5. Now this pattern can be summarized as an equation: n square is equal to n minus 1 the whole square plus 2n minus 1. And 2n minus 1 is what I call the odd difference of the number. Now these odd differences of numbers are actually an arithmetic progression, that is 3, 5, 7, 9 and so on. And you will find this arithmetic progression right here. As you can see, 2 square is equal to 1 square plus 3. The 3 is the first term of that progression. And yeah, that's how I derived this formula. Now the practical use of this, like why do you want to use this formula, is basically for children and for students who are sitting in exams, and even for people who don't have access to calculator at the moment. So this becomes much easier than to multiply 3 digits by 3 digits. So yeah, that is the practical usage of this. And once again, the paper having more details and more detailed explanation is linked in the description below. And if no one has solved it yet, I guess I'm the first, but I'm assuming that people might have solved it, because come on, this seems to be a very common equation. Either way, thank you for watching this video. I really appreciate it, and I also appreciate my friends who pointed out my mistake in my original formula, which motivated me to work on another one, which I ended up finding and made a video about it. So thank you for watching this video. I hope I made your square calculations easy, and yeah, see ya.